In this lesson, we're going to look at the binary search. So with a binary search, we're going to use collections. In this particular case, we're going to use arrays. So we're going to have to import java.util.arrays. All right. Now, binary search is a more advanced way to search for a target inside of a collection. Now, binary search is extremely fast, but it does require a sorted collection to work. And that's what separates it from a sequential search. Sequential search can work on any type, whether sorted or unsorted, but binary has to be sorted for a binary search to work. Now, binary search works by continuing to split the array into halves, thus it's able to only look at a smaller and smaller data set. So if we have a collection of 100 elements, in the first iteration, it's broken down to 50, then 25, then 12, then 6, then 3, then 2, then 1. So instead of taking up to 100 searches, a size of 100 could take as few as 3, or maybe at a minimum, it could take, at a max, it could take 8. Since the collection is sorted, the program examines the middle value. It can determine which side of the collection the target is on. Thus, looking at the middle of a collection of size 100, the program no longer has to worry about 50 elements that it knows the target can't be in. Now, binary search returns the first occurrence that the target is found at, or -1 if the target was not in the collection. Now, the first occurrence does not necessarily mean the first time that it occurs at, because it could potentially find, if you had a number of repeated numbers in a row, it could find any one of those. Unlike sequential search, which will always find the absolute first one, but binary search will just find the first one it finds, which is not necessarily the first one in order. So here's some examples. So you'll notice here that our array is sorted -2, 2, 4, 4, 5, 7. So if our target is 7, it returns 5, and we keep going. You can see all of these will work. Returning 2 if I'm looking for a target of 4, -1 if I'm looking for a target of 0. Now let's look at how binary search actually works. So binary search takes an array and a target. Okay, that's simple enough. It works the same sort of way, same sort of parameters as sequential search. But here's where it starts getting different almost immediately. If the array length is equal to 0, there's nothing in the array, therefore it can't be in the array. It returns a -1. But then it's dramatically different. So I'll have 3 variables: first, last, and middle. First, last, middle are actually representing index values. So first is 0, last is the array length -1, and then middle is your first plus your last divided by 2. So first and last are indicating the first and last position inside the array I'm worried about, and then middle is the middle of those positions. I'm going to do a while loop. Well, first is less than or equal to last. So in other words, as long as first is still on the left side of the array and last is still on the right side of the array, we're fine. But once first and last go past each other on opposite sides, then we're done. And this comment is explaining what this is going to be doing. So if the array of middle is less than target, that means the target is on the back half. If the array middle is equal to target, we found it. Else it means the target is on the front half of the array. So I'm going to be manipulating my first and last position to change where I'm looking at. So if I know it's not on the back half of the array, my last changes position to where my middle is. If I know it's not in the front half, my first moves to where the middle is. So let's review this again. So if the middle is less than the target, if middle is less than the target, that means that it's not on the front half. Therefore, my first moves past the middle. If the middle is equal to the target, I found it. Else, this means it must be in the front half. Because it wasn't in the back. It wasn't here. It wasn't in the front half. Here it's at the middle. Therefore, it wasn't in the back half. Therefore, my last now moves to the middle position. And then my middle is set again to the first plus the last divided by 2. So I'm constantly changing where I'm looking at. And if I never find it, I return -1. Because if I did find it, it would have returned middle. So let's run it. Let's see if that works. You can see it returns the values we thought it would. So if it's returning 7, you got to think about what's going on here. It's returning 7. Our front would be 0. Our last here would be index 6. 0 plus 6 divided by 2 is 3. And it keeps going until it finds the position. So it's not here. So the front would move up. Front would be here. Back would be here. And it's slowly, the front and back are moving closer and closer together until it finds what it's looking for. And that is the end of this lesson.